Hello, everyone. Welcome to ITS 454. Today, this is the second week of the course. So today we're just going to continue with our discussion of sniffing and spoofing as it relates to network security. Let me just get everyone admitted in here, and then I need to take the course participation. If you remember, I have to do that. So make sure your names are clear on your description there. Take a picture. I have to do this just for the first 2 weeks. Okay. And I think that is everyone. All right, so hopefully I've got all the names for course participation. Okay, so now all right, so today we're going to continue our discussion. Okay, let me make sure everything is recording. All right, so it's recording. Volume is on. Okay. All right, so let's go back to Brightspace. So as you know, I think I've mentioned this a couple of times. This course is a very lab-oriented course. It's not very much or too much about lectures and things like that. It's more about working through the problems. Okay. So today, if you remember, on last week, Thursday probably, I went over a lot of the details of the lab, at least some of the first details, right? Today, I'm going to do the same. If you notice, we've covered the module and security axioms, and now we're covering sniffing and spoofing, these two topics. So the way that I want to do this, because there's a lot of material in these labs, is that I'm actually going to create 2 links of homework for the sniffing module and 2 links of the homework for the spoofing side. So if you notice, what we're doing is we do sniffing both in C++, and then there's a sniffing part in Python, and then the same thing applies for spoofing. Spoofing in C++, spoofing in Python. So that'll make it a lot easier for me to grade, okay? Because when homework is too much homework in one document, it just becomes very difficult to grade. So I like to keep things into separate little units. So that's what how we're gonna proceed, okay? Really, I haven't given you a deadline for any of these. So just be on, you know, you'll see it though when I create the links on Brightspace. Basically today, I'm gonna talk about the continue discussing the lab, the parts that I haven't covered. As I said, this is a very lab-oriented lab, basically. So today my plan is to finish up sniffing. If you think about it, we covered it from the C++ side last week. Today we're going to cover it from the Python side, and then I'm going to go into the spoofing part. We'll talk about that problem, how it can be done with a C program, and how it can be done with Python. And just be aware, we'll be using both throughout the semester. We'll be using C, Python. However, my focus will not be so much on C. Whenever you have to do anything with the C language, I've always provided the code for you. And really, it doesn't require that much coding as much as it will require, what do you call it? Just kind of using the program, basically. So last week, I went over these documents. As you can see, we have actually 2 documents that we have to work through, okay? So what my recommendation is, go through these 2 documents in full, okay? Now, these 2 documents are the same 2 documents that I have in the spoofing section here. They're the same ones. This one and then this one. Let's call this one the old one, this one the new one. But basically, they're the same 2 documents that I have in here as well. So the only reason is I kind of want to break this up into two concepts, and I want to have some more, you know, I don't want to have one single document with everything. I want to be able to grade it into individual little units, and that's better for you because it's more points that you get. So more labs basically. So the idea then today is I'm gonna start with the old sniffing document, kind of go over that one, kind of emphasize that one. Then I'm gonna go over the spoofing part, and then also we're gonna move to the new document and just kind of cover the same things. Again, because we're kind of moving between these two documents, just make sure you read through them thoroughly, okay? But that's ultimately, that's how we're gonna separate it out. I thought about it into these 4 separate units, and I'll specify there when I create the assignments. All right, so let's go to the sniffing link. And by the way, you know, make sure a lot of these, remember, we're talking about systems, complex systems. So these labs are complex, okay? Don't expect them to be tutorials. Instead, you kind of really have to read through all these documents, okay? Make sure you read also through the slides, because a lot of what I'm going to explain today is already written there. And so there should be some information to help. So everything, somebody's asking me what parts of the lab have to be done. Everything in both labs you have to do. Make sense? There is no this part or that part. Okay, so you'll have to do everything in both labs. That's why we're, you know, as I said, you should have started already, and pretty much all semester will be like this. It's just, you know, a very, you know, it's an open lab all semester, really. Okay, but as I said, I'm always flexible in the sense that I want you to be doing the work, and that's why I keep saying eventually we're going to have to start doing demos of these labs, because they get a little bit more complex to implement, given all the systems involved. So anyway, read through these slides. They provide a lot of very valuable information. A lot of the things that I will say today are already in those slides, kind of summarized. Also, I strongly recommend that you read the chapter in the book. This what we're doing right now, sniffing and spoofing, ties really well to chapter 15, I think. I have the book here. And remember, that a lot of these topics align with the book. So yeah, packet sniffing and spoofing, chapter 15. So remember, read through that. All right, so let's go over, first of all, sniffing. And, you know, this is something that I talked to you guys last week, but I just want to emphasize. So you should be seeing this assignment. All right, so I already went through the description. Remember that I asked you to answer these 3 questions, but you have to basically do these 2 first. Remember, the key thing is you need to get that sniffx.c code. I already told you where to get it, showed you how to compile it and everything. And then you have to, you will have to basically capture packets, right? So remember, you have to change the filter expression for these packets. So you have to look for Icmp packets, TCP packets, and then also you have to capture the password when you use telnet. Okay, so that's basically what I covered last week. Okay, and the program for this one, sniffx.c, is of course written in C++. Okay, now that will be, so basically these problems will be in one assignment. Okay, I just want it to be like that, to be cleaner, easier to grade. Then in the spoofing module, you will submit the things related to spoofing with C++. Okay, and so all we're doing, if you remember, we're not going to be coding all semester, but at the beginning of this semester, we want to basically, remember that analogy I gave you. We want to take the car and see under the hood, right? We want to see how the code works. And that gives us, because everything is built on top of this libpcap library, pcap, so it gives us a good intuition into how to do other things. So what I'm going to talk about now is this idea of spoofing. Remember, spoofing is about creating fake packets and sending them in the network. So this is very useful when you're doing an attack, okay? There's really just one problem for this one, which is problem 8. And then just like with the previous part, you'll have to answer these two questions, 6 and 7, okay? So we're gonna do this now. This will be another link. And then after that, I'm gonna switch to the new document, where in the new document, we look at scapy and we look at Python and how to do sniffing and spoofing in those languages, in that language. And, you know, scapy we'll use again when we do intrusion detection things. You know, basically when we do attacks, we're going to try to take this same approach, okay? So are there any questions before I get started, guys? Any questions? All right, I did notice that some of you came in late. So just to kind of give you, I don't miss you in that course participation, I'm going to take a picture again. I usually don't take, you know, it doesn't bother me, but it's just, I had already taken the pictures. I'm going to take them again. All right, so hopefully I'll get everyone. Oh, okay, so I think hopefully no new people will come in because I already taken the roll call twice. All right, so and as you know, at the end, you just need to submit a we don't have I'm sorry, guys, I'm just reading the comments. Somebody's asking, do we have a due date? What is, for what? For the homework? Is that what you mean? Yeah, not, as I said, so these labs are very involved. So it's more of a, I'm going to see how you guys are doing. And when I feel that a lot of you have completed things, I'll kind of start setting the deadlines, okay? Giving you a week, of course. So basically what I would say for this one, I would anticipate that all 4 links of this sniffing and spoofing would be due by, or at least the first 2 would be due by next Thursday, okay? Sound fair? That we don't have a submission every week, but you are working on bigger labs every week. That's really what it is. All right, so today we're going to talk about, as I said, spoofing. So you should be seeing on the Brightspace task 2 spoofing. Okay, so this is the one that focuses on C, the C programming language, which is the most raw. It's also the most powerful. So it's obviously what, you know, netcat and nmap and all those libraries are going to use. So what do we have to do here? Now, the easy thing about this lab is actually, I have already given the C code to you, all right? So I have the solution. It's already posted on Brightspace. You literally, all you have to do is run it. It should be pretty straightforward. But again, I want you to get a feel for what's going on. It's an interesting problem. So let's talk a little bit about it. So spoofing. When a normal user sends out a packet, operating systems usually do not allow the user to set all the fields in the protocol headers, right? So, you know, such as TCP, UDP, and IP headers. They can't change a lot of those. Usually the only thing you can change is like the IP address because, you know, wherever you're sending something, right? But otherwise, you can't really change any of these parameters. OSs will set most of the fields for you, while only allowing users to set a few fields, such as the destination IP address or the destination port number. However, if the user has root privilege, and that's why questions 6 and 7 kind of go into that, if the user has the root privilege, he or she can set any arbitrary field in the packet headers. And this is essentially packet spoofing. So packet spoofing is literally grabbing a buffer in C and figuring out what the data structures of a packet look like, mapping every 20 bytes or whatever the size of each header is to a data structure, right? And I'll talk a little bit about that. And then you just set the parameters. Set the parameters in the code, and boom, you have a packet, and you've created it from scratch. And because you have access to the network card through the network's raw socket, you can actually put that packet on the line of the network, and basically now you've spoofed the packet. So that's really the idea. So if the user has the root privilege, she can set any arbitrary field in the packet headers. And this is essentially packet spoofing, and it can be done through raw socket, what is called through raw sockets. Now, I'm not going to specify so much like syntax of code. That's not really my goal here. You guys, can figure it out on your own if you ever want to do it. I'll explain the logic of how it works, and then, I just want you to understand the basic concept. Raw sockets, give programmers the absolute control over the packet construction, allowing programmers to construct any arbitrary packet, including setting the header fields and the payload. All right, so we'll learn basically how to do those things, how they work, because they give you a lot of power. Using raw sockets is quite straightforward. It involves 4 steps. You create the raw socket, you set the socket options, you construct the packet. That's the key thing. You construct the packet, and then you send out the packet through the raw socket. There are many online tutorials. As we saw last week, I showed you one, right? That teach how to use raw sockets in C program. In this task, we will not focus on any specific tutorial. Your task is really you can read the tutorials as I suggested. Hopefully you read Karsten's tutorial. And then you can either write your own packet spoofing program or just download the program I've provided. Okay, just use that one, which is on, there's actually 3 or 4 versions of it. What I would call is, I have a version that's like if you really want to do everything from scratch, and then there are other ones which are just more efficient, more compact. I'll recommend which one I think you should use, but I leave it to you. I certainly do recommend that you read all files. So you will use those programs that I provided, and then you'll play with the program, and then you have to solve these. Now, keep in mind, really, for problem 8, you will actually need to, the program actually does sniffing and spoofing at the same time, right? So you're actually going to end up doing both tasks at the same time. So you'll need to answer the questions. In your own words, describe the sequence of library calls that are essential for packet spoofing. I'll sort of describe that today, but I do want you guys to do that on your own, as a summary. Problem 7, why do you need the root privilege to run the programs that use raw sockets? So I just said that. You should be able to answer that question. Where does the program fail if executed without the root privilege? You'll need to think about that one. All right, so here is the scenario, okay? And it's actually quite interesting. So there's a few things that I'm looking for in this problem, okay? So first of all, so the question, there's only one problem, as I said, and it's this one. Please combine your sniffing and spoofing programs to implement a sniff and then spoof program. This program monitors its local network, right? So it's monitoring the network. Whenever it sees an ICMP echo request packet, remember, an ICMP packet is a ping packet. When you send it, it's called an echo request. When you get back something, it's called an echo reply, right? So basically, you want this program that whenever it sees an ICMP echo request packet, it should spoof that packet, so make a copy of it, and then from it, modify it to create a echo reply packet. So you can see where this is going, right? Therefore, even if the victim machine pings a non-existing machine, it will always see that machine as alive, okay? So you'll have to include in your report screenshots to show that your program works, and you can, describe your code. So let's look at that scenario. Remember that this whole class is like this, right? We're going to run through little scenarios of different things, different concepts. Usually we have labs. Sometimes they may just be problems kind of on the board that you'll have to solve on paper. But in general, though, hopefully we'll have a way to solve them. All right, so let me switch over to the whiteboard. All right, I just want to lay out the problem and of this one, Sniff and Spoof, the spoofing lab. So the idea is as follows, right? The idea is as follows. Let's say that you have a machine. You open a terminal, right? And you ping from this terminal 1.1.1.1. So that IP address does not exist in your network, right? So you ping it. So the terminal basically just shows like ping, but there's nothing, no output, right? It just kind of gets stuck in there, gets stuck. You'd have your network, however you want to create it, right? You'll need at least 2 machines, probably. One of the machines needs to be the one that pings, right? Let's call it A machine. They can both be seed Ubuntu's. Then we have B. What does B do? B will have the sniffer code, right? One of the programs I've provided. So what it needs to do is, if you're just pinging 1.1, let's say that 1.1, it's going, so it's going to 1.1.1, but there is no 1.1.1, right? However, you need to change the monitoring of the network card on your sniffer so that remember that in promiscuous mode, if it's not in that, it will only accept packets directed to B. So you have to change that mode so that it can actually scan every single packet being sent out in the network. Okay, so that's probably the first thing you want to take a look at. Once that happens, your sniffer code or sniffx code in C in this case should grab the packet, right? So it should pick up the packet. Once it grabs the packet, and the code, has all this functionality. So first it grabs packet. Then it's going to make a copy of it, right? We make a copy to another then we make a copy of the packet, a second one. So let's call it PKT2. You can also call it buffer, whatever you want. I think I called it buffer in the code. And then number 3, you need to modify some fields. In particular, I don't know what structure you have, right? I don't know what IP addresses you're using. So you'll need to play with that. And then once you change those, modify those fields, you get a new packet, PKT2, and you send it out back in the network. Right? Remember that whereas this is an echo request, because you modify that as a field, right? You modify that. It's an ICMP packet. An ICMP packet here will have what? It'll have an Ethernet header. It'll have an IP header. It'll have an ICMP header, right? So you need to take a look at the code to figure out where you need to change that field or if it's already set there. But it's going to be from echo request. The network card, let's say this is the network card, because your sniffer program is now locked into it, will create this new packet. Let me just draw it in this way. And now, what's going to need to happen is that the source IP is going to be 1.1.1, right? Because now it's going back in reverse. Additionally, instead of an echo request, this is going to be an echo reply. What's going to happen on the pinging machine? The A machine will get that echo reply, and it'll be tricked into believing that, in fact, hey, you know what? I did get a message, but it's a message because you are sniffing and spoofing the packet, right? And that's basically the idea. So this should be a pretty interesting. You will get, I will sort of warn you that once you get this to work, you get a little message in the ping output that says dupe. That usually, when you run ping normally, you don't get this, right? So I need you to figure out also how to get rid of that dupe. So it'll be great. You'll feel good when you get some replies, but just make sure. I need you to answer the question, why am I getting this dupe? What is that? And then solve it. And it's actually a pretty easy solution, but you just have to really think about it. Again, if it's not a coding assignment per se, it's more of a, getting these scenarios. And, pretty much all semester, we'll be running these scenarios, okay? We'll create like some kind of a networking type of a thing with packets, and then we will look at network security, right? And you can see here, the whole point is to understand that these attacks, this new class of attacks, is trying to take advantage of some of the ways that the network works and packets and so on. All right, so another thing that might be a little bit important for me to mention, and this is in the slides too, is that whenever I say we're going to create a buffer, right? You know what a buffer is. If you've taken 450, although this is not a requirement for that, you were very familiar with creating buffers there. We created several ones. So here we just have, a variable buffer of size and whatever it is. On top of that, we have some data structures. Structs, right? So data structures. So we have some data structures. Structs, you will see those throughout the code. And they're basically ways of grouping information. So all headers, let's say the IP header, right? The IP header, it's really a struct, right? It's a struct of, some fields, whatever, 20, 30 different values. Then you have the Ethernet header. And the Ethernet header is also, 20, 30 fields. They have usually a size like 20 bytes, something like that. And then there's the other ones, right? So there's all the other ones that we would have here. What are they? TCP, UDP, ICMP. These are the common ones. So these are also structs. And then finally, we have, we will have the payload. And some packets will have payload. We'll see some examples of how to do that as well, okay? So what I want you to understand is that I'm now just gonna take an example, right? So I'm gonna take an example and just say, I'm just gonna take TCP, but this could be UDP, okay? This could be anything. So TCP header. which is a common one in some of the attacks, and then also the payload. Okay, so basically what you do in C is that you use what is called vector arithmetic, right? So with vector arithmetic, you create pointers. You create pointers of these structs. So you'll create a pointer, and the first Ethernet header will point to the beginning of the buffer. Then, I'm going to switch colors here. The IP header, right? You know, let's say there's an offset of like 20 bytes, you know, something like that. Right? And so now you're going to, the IP header pointer will point there, right? So that's where the data structure for the IP header begins. And then you just continue doing that for the TCP header, right? And the pointer associated with that struct, you know, will point to that offset. And then finally, the payload pointer will point to that. So that's really all that you need to understand, honestly, in this, right? So whenever, and then there's going to be a whole pointer, let's say buffer, right? So we basically started buffer, and then we just need to calculate the offset and figure out where the next header begins, right? So that's pretty much what we would do. So something like, let's say we want to modify or access the TCP header, you know, we can create a variable, let's call it, you know, var1, something like that. And it's just going to be buffer. And let's say these are also 20 bytes. So it would be plus 40, right? So plus 40 bytes gives you the nice offset that would get us there. So basically then, var1 points there, right? And var1 then just becomes an object of data structured TCP header. And TCP header. And now var1, if I switch over here, var1 dot something, you know, destination port, right? Destination port. And so now we can change that value to whatever number we want, 22 or something like that. So that's really how it works. You create a variable. The variable is a struct, so it'll have access to the data structure, which is, you know, these parameters here, right? And all we have to do is we kind of have to map that buffer plus its offset, right? We have to map it to our variables, and then that way we can modify all the parameters in the packet. That's how it's done in C, okay? And you will see in a second, once we look at the code, that's basically the very straightforward. In Python, it's going to be even easier, but this just gives you a little bit of intuition of what we're doing. So this page, you know, and this page are really just to kind of help you with the code to make more sense of it. This is really where I want you to focus your attention, though. All right, in a lot of these labs this semester, this is how it's going to be. I need to see the output. So for instance, the screenshot that I'm looking for is this one, right? I'm looking to a ping that receives. It's got, you know, receive, you know, from 1.1.1. I need to see that output that you usually get, and you'll need to make that happen. Please, as I said, all of these labs need to be done only in C or Python, okay? This is the only, I've provided all the code, however, okay? This is, and I'm not asking, I don't want you guys to start writing code from scratch. Okay, we're not gonna use Java here. All right, so so that's basically the setup, okay? That's basically the setup of what we're doing. So let's go back to the PDF. So I've talked about all of this, so consider this discussed already, okay? So now I'm gonna go back into the lab. All right, we've got our security axioms. I've covered this document in full. And that. So now now I've covered SniffX, right, last week. So you should know hopefully you've done the SniffX part already. And then now what I'm going to talk about is how to do this spoofing part, okay? So notice I have 3 files in here. Mem Copy, Sniffx Spoof, Sniffx Spoof, and Sniffx Spoof 2. You only need to use one of these, okay? So it's basically 3 versions of the same thing. They're only there for, like for your information. Really, I would recommend that the easiest one is Mem Copy Sniffx. Okay, I'll open these in a sec, but you will see these are that's the easiest one. Okay, so I've opened the files now, so I'm going to go ahead and open them individually. So I'm going to share this with you guys. All right. So you should be seeing Notepad++ now. You should be seeing Notepad++. So you can see this is very, very much the sniffx.c program that you already started using, okay, by Tim Karstens. So it's the same program that you used. I will just point out a few things here and there. You can read through this script. I won't ask you too many questions about this on the exam. And in particular, I'll be just looking for general understanding. So here, these are the structures that I was talking about. As you might imagine, there's values. Everything is correct, though. You can see here there's sniff IP, and these are the associated parameters. So I do certainly recommend that you explore all of these. This should be consistent with what you've learned in your 270 courses, your networking, where you learn all those protocols and fields. Then there's the struct for TCP. You can see that there. There's a few functions like got packet, which we will be using, and then a few helper functions as well, okay? So you can see those, how to print hex to ASCII and so on. We'll just be using these, okay? Printing the payload, but in particular, there's one function that is important, right? Which is called the send ICMP reply. So if you remember, I said that we need to sniff the packet and then you send an echo reply, right? So this is the code where you sort of do that. Okay, so I will just briefly address that. So that function is important. We will come back to it. Got packet is a built-in function that handles getting packets in this program. And in particular, you can see there's a switch in here. So the got function grabs the packet. You can imagine it that it works that way. It grabs the packet. It breaks it up into the headers, maps everything in the header. You can see that's being done here, right? It takes the packet and it just kind of maps it. And now, through the fields, you can check, you can grab the IP header. You can see that here. I have grabbed the IP header, and now I'm going to check its protocol. Okay, so if it's a TCP packet, doesn't really do anything. If it's a UDP packet, doesn't really do anything. However, notice what happens if it's an ICMP packet, right? If it's an ICMP packet, there's a function in here called send ICMP reply. And it actually sends the current packet, right? So that's really what you would want in this program. It grabs the packet, it checks to see if it's an ICMP. It is. Okay, great. If it's an ICMP, I just send it to ICMP reply, and then ICMP reply will do most of the heavy lifting, okay, most of the heavy lifting. Okay, so you can see that, once you do that, basically that's it. The whole program starts at main. You can see that here. The filter expression is here, remember. That's what you're doing in the first part of this, just playing with the filter expressions. Here, you have to make sure it has the appropriate filter expression, right? You're trying to capture ICMP packets, therefore, ICMP might be of interest. You can also think of changing the number of packets if you'd like. That's up to you. But that's basically it, right? So you define the function. The function is sort of running in the background, right? It's running in the background, getting packets in a loop. Okay. See, notice the most important thing of all of this is you have pcap in a loop. It's kind of hooked into the pipeline of the packets. Any packet that it grabs, it sends to God packet. Okay, God packet. Then if we go back to God packet, which is this one I already have highlighted here, as I said, it grabs the packet, checks the protocol. If it's an ICMP, it calls send ICMP reply and sends the packet. So now if we go to send ICMP reply, you can see that over here. We grab the packet again. We create the structures, as I said, which is the thing I just explained in the slides. We kind of map the pointers to that buffer. And then once we have the headers, we can just proceed and create our new packet. So here we create a raw buffer of size 400. We zero it out. And then notice here, we can grab all the parameters. So for instance, you can grab, IP source address, right? IP source, IP TTL, and so on. You can see here, if it's for instance, the type ICMP echo reply, echo request. As I said, this is the hardest way of doing it. I started with this one, but you don't have to use this code. You can simply use Mem Copy, where Mem Copy just covers just copies everything. Whereas here, you're literally setting the parameters by hand. Okay, that's the only difference. Okay, once you've set all the parameters correctly, right? I do recommend that you read this through this just for your own knowledge, right? All you have to do then is you create the raw socket. You can see that here. Set some parameters, some options, some default values, and then finally you send the packet buff. Buff will be, as if you remember, is the original packet. You copy some of the fields, but also the modified packet. And that's it. That's literally all you have to do, okay? So I leave it to you guys if you want to use this code. If not, you can always just use Mem Copy. So let's take a look at that one as well. Okay, so I open Mem Copy. Let me see if I'm sharing it. Okay, so I should be sharing Mem Copy now, right? Mem Copy is the same Sniffx code, just a little bit more efficient, more cleaner. Pretty much the same thing, so I'm not gonna explain everything, right? Same pcap loop, got packet, same idea. Then you go to got packet over here, right? Grab the packet, same idea, check the protocol, same idea. Here you can see if it's an ICMP, if the protocol is ICMP, which is a ping packet, I called send ICMP reply. Okay, notice here you're grabbing the current packet, right? The one you just sniffed in the network. Okay, so now you can go ahead and you scroll up to send ICMP packet, right? You can see send ICMP packet over here. Same thing, you kind of create the structures over there. And you can see this code is a little bit shorter, right? It's a little bit shorter. And this one, the advantage of this one is that it's just going to copy the buffer, right? So it's just going to copy the old packet into the new one. Okay, so you don't really have to do anything. You set, and then some of the parameters are already set for you. Now, the only thing where you might need to look at this is in these fields, okay? So I would say probably like the IP addresses, check them, okay? Make sure that you've got the correct values there. Okay, and then this is just the same thing. These are just kind of standard, default, I mean. And then finally here you create the socket, and then once again you send the packet out into the network, okay? So that would be probably the best way of doing it is just using this code. You can see here's the mem copy. That's why, hence the name of this file, because that's really the most important thing, right? That makes your life a lot easier by mapping this packet over here, which you can see here, right? By mapping this to buff instead of setting all the fields. So then all the fields are kind of set for you. And then after that, you just have to modify a few of these. So certainly read through this, try it, play around with some of the values. But as I said, usually you just have to change. If you have to change anything, it will only be fields like these that have values. But for now, use the default ones. Okay? And then once that happens, hopefully you will get the echo request sent back out into the network. Okay? Does this make sense, guys?
Yes.
Okay, great. All right, so that's it. You know, read the code just for your own information. You know, you'll have one of the questions on the lab is describe in your own words, right? So kind of what I've just described. Second, change some of these fields, but ultimately through this program of Mem Copy. So if I switch back to the, as you can see, it's actually simpler than you think. If I switch back to this one, right? So you use Mem Copy, and your goal, if I go back to the whiteboard, is to just solve this one problem, the one that you see on the screen. Sending out ping packets, right? Sending out ping packets, and sending out ping packets. And if you send them to 1.1.1, well, you know that doesn't exist, right? So, and you have to use 1.1.1. This is how I will know, you know, that you're using something that doesn't exist. Then I need to see the replies, and then remember, you'll get this dupe. You need to figure that out as well. That's it. I mean, the problem I should think, you know, when I first saw problems like this, I always thought they were so interesting. So I assume you think they're interesting too. Take a look at them. Again, this will give us a feel for how sniffing and spoofing works. And then that gives us then a feel of how networks work, you know, in terms of attacks, in terms of defenses, because you have an intuition. Oh, wait, no, you know, probably this protocol or that protocol might have a vulnerability. Remember, this is a new class of attacks and defenses, all related just purely to the network and how it works. So that's why we look. So, you know, if you remember, I said, what does a marine biologist study, right? You guys said dolphins, and marine life. Well, here, what does in network security, what's the key thing? Actually understanding this, right? Understanding that relationship, understanding, yeah, this in general, right? So these data structures, which allow you then to grab the individual little fields of all the headers. Eventually, we'll even grab information from the payload itself, right? Payload. But that's what, and we'll take a look at some papers, some research papers that we worked on over the years that should be interesting as well. Whenever you're doing network security research, you know, PCAP, the PCAP file structure is always going to be very important. Okay. All right. So now that we've talked about this, I think let's go back to, yeah, so I've covered the files, this one in particular, and I've covered the old one. So at this point, the old sniffing and spoofing document has been covered in full, which basically means the C part has been covered in full. Okay, let me add now, or actually let me wait until I cover the new one, and then I'll add the links. Okay, So before I move on to spoofing new, which is the new document, are there any questions? Anything that you didn't understand, that you're confused about? All right, great. Sounds like everyone is clear on this. All right. So let's go to spoofing new. Notice, again, like I said, they're the same document. This document and this document, they're the same one. Okay, so let me share the document. All right, great. So this is the spoofing, this is the sniffing and spoofing, the new version, which now includes Python. We're also going to work on this one because, as you know, Python is more accessible than, say, writing code in C. However, you now know how to do it in both C and you will know at the end, at least, of this week how to do this in both C and Python. So let's go over this one again. So we've already said that packet sniffing and spoofing are important concepts in network security. All tools, basically Wireshark, TCP dump, scapy, they're built on top of these ideas. But it's important to understand how these tools work, how packet spoofing and sniffing are implemented in software. So we want to understand the tools and technologies, and basically to be able to write very simple sniffers, and that we will be using for the rest of the semester. Whenever we need to make an attack, for instance, we either will use netwalks, or we will use netwalks, or we will use scapy, or whenever you want to sniff something, you can use this code or something. So here we've already talked about sniffing and spoofing. We've already talked about the PCAP library, and now we will talk about scapy, which I probably covered this briefly in 372, your sysadmin course in Linux. But again, we'll do some examples here. And yeah, so manipulating packets in scapy. Remember, you should be reading, this aligns really well. I took a look at chapter 15. This aligns really well with it. So certainly take a look at it. Okay. The lab environment, we'll be doing this with the 1604 VM. You can try it with the 20 VM, but as you can see, this has mainly been done with the 1604. But I wouldn't anticipate any problems. So you guys know about this. All right, so here is now using tools for sniffing and spoofing packets. Many tools can be used to do sniffing and spoofing, but most of them only provide fixed functionalities. Scapy is different, right? So that's what's great about it. It's not like Wireshark, and it's also not C. It's somewhere in between. It can be used not only as a tool, but also as a building block to construct other sniffing and spoofing tools. And that's really the hope, right? That you guys will be able to craft your own scripts whenever if you ever start to do research, and which is what hopefully you'll end up doing to solve real problems, right? If you just want to, that's script kiddies, right? You want to just know those basic attacks. Well, some tool might be fine, but if you're really getting into more 0-day or current things, you'll have to be able to have more flexibility, right? And so something like scapy certainly, or C programs, will help you with that. So we can integrate the scapy functionalities into our own programs later on. So here, this lab is very simple. It's just meant to kind of get us into the mindset of scapy. If your VM 1604, I'm almost sure that the version it has by default is Python 2.7. So you will need to install Python 3. I would recommend that you use Anaconda, right? Take a look at how that works. It's very easy. Install it on your Linux if you can, and that way it's a package manager that allows you to install multiple versions of Python on a machine. Otherwise, just follow this command. This command should also work. Pip3 install scapy, right? But just be aware that you should have Python 3 on there as well. Okay, so to use scapy, we can write a program and then execute this program using Python. Also, by the way, I should say, if you use the 2004 version of Seed, it'll probably have Python 3 by default. So there's actually an incentive right there to have both, right? To have the Seed. It doesn't matter to me which one you use, because at the end of the day, that's what's so great about this, right? You have a 1604 that could be the attackee, and then the attacker is 2004. Well, 2004 generates the code in scapy Python 3, but it doesn't matter because what you end up with is a packet in the network, right? And that will work regardless of the version of Python. So certainly then here is an incentive for getting the 20 version. So now let's get a little bit into the scapy program. So we can write a program and then execute this program using our Python code. Here we see a simple example of how that works, right? And hopefully a lot of this should be very familiar to you. You will need to run this program with the sudo privileges or root privileges, obviously, to be able to get access to the network card so that you can actually set the parameters. And so now let's take a look at how this works, okay? So as you can see, the first line here is the shebang, which basically says by default, if it's an executable, run this in Python 3. Remember that if it's in Python 2, the code will not run, it'll break. We import the scapy after it's installed. And then notice how easy it is to create a packet now. Whereas before in C, we had to deal with all those structures and pointers and pointer arithmetic and all of that. Here, all we have to do is create the header, IP. One important thing is that all these headers have default values. So usually it's okay just to create the header, right? And take the default values in it, right? You don't really have to set much if, only the things that you really need for your specific problem. Like in the case of 1.1.1.1, right? We need to get that IP address in there. So we create a variable A, and then we say that, so packet's an IP packet at this point. We can use the show to see some information. So it gives you some information, all the fields in the IP header, as you can see here. And then after that, make it executable with chmod and then just run it, right? When you do this, hopefully it'll just print out the results. So we can see that here. You can also run this, remember, in the prompt just to get it a little bit more interactive. That's basically how scapy works. Library, create the headers, as you can see here, and then obviously we can add more functionality to it. But that's the basic code that you would have on there. Now, for a more complex problem, we can look at sniffing packets. So remember, one of the things I will ask you to do is these tasks, right? So as you know, Wireshark is the most popular sniffing tool. You've used it many times before. I actually recommend, so here's something interesting. As we start doing all these labs, you will always need, the problems are going to get harder and harder. So to help yourself, you can use Wireshark to kind of figure out, okay, what does the packet look like? Which packet did I put on the line? So I certainly recommend that you do some review on individual, on how to write the filters for Wireshark, right? So that you can always filter out the packets that you're getting. You'll see later on that it'll become very useful. But here we can see that, you know, it's easy to use, and we will use it throughout all the class basically. However, the problem with Wireshark is that it is difficult to use Wireshark as a building block to construct other tools, right? Because it's more of a standalone. So we will use scapy for that purpose. The objective of this task is to learn how to use scapy to do packet sniffing, you know, in the network. And so now I'm going to go ahead and, just like I did before, kind of describe the code. So as you can see, it's actually pretty straightforward. All we need is this magical function here called sniff. Okay, that's pretty much all we need. So again, this works with Python 3. The basic pipeline is that you import the library, okay, and then forget about this for now, this function definition, and just jump ahead to this. So we call sniff. Sniff actually will return a packet, you know, whatever it sniffs. But in particular, we can specify here a couple of things. We can specify the filter, that is to say what we want to sniff. So for instance, an Icmp packet. And then we also specify what sniff should do with the packet that it just got, right? The packets that it just got. So for instance here, notice we call the function print_pkt, which is actually this function. So as you can see, you know, it basically works in the same way that the C code works. Exactly the same idea. You know, we have a loop that is capturing the packets, and then that loop calls a function. It passes the packets to that function, and then here you can add whatever code you want. Make sense, guys? All right, so I'm assuming it makes sense, or you're all terrified. All right, so now that we have, now that hopefully we understand that. So that's how you do the collection of the data by using this sniff function. So the above program sniffs packets. For each captured packet, the callback function print_pkt will be invoked. This function will print out some of the information about the packet, right? Or whatever you define it to do. So what you have to do, though, is you have to run the program with the root privilege and demonstrate that you can indeed capture packets. After that, run the program again, but without using the root privilege, and describe what happens. Okay, you can see that here. You make it executable, and then run it with and without sudo permissions. Okay? All right. After that, now comes that was just like the warm-up, right? That was just like the warm-up. Now comes the fun part, which I'm sure you're. So here's a couple of problems. Very similar to the ones in C, right? So the only difference is you will do them in Python. This is, of course, one of the main things I'll be looking for. So usually when we sniff packets, we are only interested in certain types of packets. We know that, right? We want to capture some particular things. We can do that by setting filters in sniffing, okay? Or in sniff. Scapy's filter, the Scapy's filter uses the Berkeley packet filter syntax, which is the same one as Wireshark and all the other ones, right? So you can find the Berkeley packet filter manual over the internet. And that's what I was saying, just kind of explore, you know, how Wireshark does it, maybe find this manual. You'll have that. This one suggestion will help you out for the entire semester, because we will be going back to this idea of how do I craft this? How do I craft that? Now remember that the other side of this coin of crafting rules, these rules for sniffing, is that it's also consistent with writing rules for firewalls, right? So if you want to block something, right, you know, how do you write it? Well, similar intuition. And that's the whole point of this, right? That by showing you one side of the coin, you get an intuition on the other side of the coin of how to do things with firewalls. Now, I'll explain a little bit more on firewalls later on in the semester, and we'll go over that as well, but not yet. Okay. So, okay. So where was I? Yeah, get the Berkeley packet filter. Find it on the internet. Get that manual. It will probably help you out a lot. Please set the following filters. Right, you're going to set the following filters and demonstrate your sniffer program again. And you can set it separately, right? So obviously capture some ping packets, easy Icmp packets. Capture any TCP packet that comes from a particular IP and with a destination port number of 23. So notice there's 2 items you need to set in that one. Then the other problem is capture packets that come from or go to a particular subnet. Okay, you can see this is a different problem now. You can pick any subnet, such as, whatever. You guys will probably have like 192.168.1. That's something. Okay, you can pick whichever one you want. You can change this. You don't have to change your network to match this. Instead, change this to match your network. I'm perfectly fine with that. So that's to make it easier. So /24, something, that's fine. You should not, so here I'm making the clarification, okay? Here it says you should not pick the subnet that your VM is attached to. I'm saying the opposite of this, okay? So make a note. Unless you want to, the challenge, that's perfectly fine. Do that, but I'm saying you can actually use whatever your VM's network is. Is that clear for everyone?
Yes.
Excellent, excellent, sir. All right, good. So that should be pretty fun, I think. Again, one recommendation I would make to you guys, if you have a hub at home and 2 laptops, I know, we are, unfortunately, we are with the pandemic, we are not in our lab equipment where we have all these network taps and switches and things. But if you have at home an old, little hub or a network tap even would be great. I don't know how much they cost. I assume somewhere around $50. If you guys have an interest in buying a network tap, what I mean by that, let me know, and I can either put some information about, what you can purchase. That would probably be very useful because you need 2 computers. So you have 2 laptops, you make them in bridge mode, right? I believe you understand what that is. In VMware, put them in bridge mode. And then those 2 laptops can get connected to the tap network. And now you have a network that is more physical than virtual, and you will be able to do a lot of things with that. So let me actually, like I said, I'm not requiring this. I'm not saying that you guys need to buy anything. I'm just saying for those of you that would like something like that, I would recommend like a network tap. Remember, I described these the other day. 4 ports, or 5, I think. Usually 1 and 5 are mirrored. And then if you have 2 laptops or a desktop and a laptop, something like that, in VMware, put them in bridge mode. And so they will be able to get physical IP addresses, and then you can create physical networks. Certainly that, might be more fun for some of you. If not, or be creative. If not, though, everything can be done with the VMs as well. But yeah, if you'd like more information about this, email me. I'll try to provide some where to buy. Okay, where was I? Here. All right, so I'm going to go back to the PDF. All right, so the problems, I've already laid out the problems here, okay, for sniffing. in Python. So remember, that's going to be one link, sniffing in Python. The next one is spoofing the IP packets. Sorry, the Icmp packets. Similar to the other problem, right? As a packet spoofing tool, Scapy allows us to set the fields Scapy allows us to set the fields of IP packets to arbitrary values. The objective of this task is to spoof IP packets with an arbitrary source IP address. We will spoof Icmp echo request packets and then send to another VM on the same network. So it's similar to the previous problem, as you can see. You can use Wireshark to observe whether our request will be accepted by the receiver. If it is accepted, an echo reply packet will be sent to the spoofed IP address. All right, so it's similar idea there. Sending out a fake or an echo request and then getting an echo reply. The following code shows an example of how to spoof an Icmp packet. So you can see here now, notice there's a little bit more now. We have the library, we create the IP header of the packet, we specify the destination, which is going to be 10.023, right? It could also be 1.1.1.1, right? And then now we're going to add the Icmp header as B. Notice that to concatenate these, notice the approach. You create a packet, which is A, the IP header, / and then B, the Icmp header. All right, so that basically creates the complete packet with the Ethernet is kind of implied that it's there. The IP header is there, and now it has an Icmp, and therefore it becomes an Icmp packet. Notice that once the packet is fully realized with default values, except for this destination IP address, you can just go ahead and send it. That's it. Look at how simple that is. Notice that it sends one packet. What if you wanted to send 10,000 packets? What do you think you would do?
Could you just create a for loop and then keep sending the same thing?
Maybe a for loop, right? Maybe a for loop. Exactly right. So note, be careful that this could create flood the network, right? If we were at the university, I would tell you right away. You should not do that at the university. You're at your homes, I assume. If you're at your dorms, don't do this at your dorms. Because these are my point is these are real packets. Okay, these are real, like like if you just connected any computer and it was doing things. Okay, so that is the code for spoofing Icmp packets with Scapy. Basically, I want you to do the same problem or something similar. If you find boring doing the same 1.1 problem, modify it a little bit. But otherwise, at least I would expect you that you could repeat the process, but this time on here, okay? Now, in the code above, we have some simple examples there of how to create the IP header, which is a class, how to provide values. Additionally, though, sometimes you don't know what the fields are of something. Like A in this case is an IP header, right? So if we think about those structs, what we want to look at is we want to look the individual fields, right? The kinds of things, as I said, you learn in your 270 protocols course. But sometimes we don't remember, so we want to look at them. So we can use LSA or LSIP to see the attribute names and values, okay, associated with that header. You can also use a.show and IP show to do the same. And then we saw in line 2 how to set a field, which I already talked about. You can play with that Now, remember, this is important. If a field is not set, a default value will be used for that field, right? So that's usually how that works. All right, so now you can see if you do LSA, you're basically printing out all the fields of an IP header. So you can see it's got version, gives you the number of bits, you know, data type, value, and so on, right? So it's got IHL, ID, some flags, right? We know flags. In IP headers, this will be important when we start doing SYN flood attacks, TTL, checksums. Usually these things are calculated by default, which is what's great. Whereas with the C program, we have to do these manually. Source and destination. So notice that by default, it uses the localhost IP, but you probably, in your scenarios, you need to specify IP. I will ask you that when you submit your labs, you can do this by hand. You don't have to do this like on a computer, but always draw out the network, put in the IP addresses, just to kind of, I can quickly understand what your network looks like when you do these things. But that's why I said at some point we will start doing demos of all of this, because it just gets a little bit harder to just get in. I'll see how you guys do with your reports, but if some of the reports I think are not 100%, I may ask you for a demo as well. Okay, so yeah, so then we create the Icmp packet. I've already talked about all of this. And then finally, you send the information. You can use the C code to maybe help you out to figure out how to do this in scapy. All right, the next problem is trace route. This one's a little bit harder. And so, but we're also going to do it. So this would be part of spoofing, right? So they're all part of spoofing now. All right, so let's take a look at this trace route. So everybody knows what trace route is, right? So you guys know what trace route is. They're commands that you've used, you know, in your classes. The objective of this task, though, is to use scapy to estimate the distance in terms of number of routers between your VM and a selected destination. Okay. This is basically what is implemented by the traceroute tool. In this task, we will write our own tool. The idea is quite straightforward. You will send a packet, any type, to the destination with its time to live TTL field set to 1 first. This packet will be dropped by the first router, which will send us an Icmp error message. Right? So you should see that on your machine, telling us that, you know, maybe by sniffing it, telling us that the time to live has exceeded. That is how we get the IP address of the first router. We then increase our TTL field to 2, send out another packet, and get the IP address of the second router. We will repeat this procedure until our packet finally reaches the destination, whatever that is. It should be noted that this experiment only gets an estimated result because in theory, not all these packets take the same route. But in practice, they may within a short period of time. They may be within a short period of time. The code in the following shows 1 round in the procedure. So as you can see here, very easy again, you know, A is IP, you know, specify the destination where you want to go. And then, you know, trace route, we can use it with outside. I don't see the problem with, you know, doing that, Google's DNS or something. So try something like that. You set the TTL here. This is really what is new. And then you specify, you know, probably a ping packet, Icmp, and so on. You'll have to have Wireshark in the background to capture the returning traffic. And then notice to create the packet, you sort of concatenate A/B, and then we send out the packet in the network. Does this make sense, guys? How to do this trace route one? Are there any questions, I should say, about it? Okay, everyone's quiet, so it seems like no questions. Very good. All right. Good. All right. So now, so I would argue that's the semi-automated way, right? Because you kind of have to repeat the process on your own. That's perfectly fine for the homework assignment. However, if you're an experienced Python programmer, you can write your own tool to perform the entire procedure automatically, right? Why not try to write your own trace route? However, if you feel that you're not, if you guys are not new, but if you felt that, you know, you can basically do it manually, just changing the TTL field in each round. And then, you know, take a notebook and a pencil and write down all the values. Record the IP address based on your observation from Wireshark. Either way is acceptable as long as you get the result. However, just be aware you can definitely do it fully automated, and that would be you know, great if you can. Okay. Last one, because if you notice, the rest is just the C stuff, and that I'm not going to ask you to redo it. Obviously, you will do it in the other one, but I would recommend that you read through this. You know, it might just give you a little bit more insight. Okay, but we'll get to it in a sec. Let's just finish the Python part. We have one last problem after the trace route problem, which should be very interesting. The last one here. This is actually, so what, this is actually the same thing as this. Maybe. The objective of this task is to spoof IP packets with an arbitrary source IP. So source, any source. We will spoof Icmp echo requests and then send them to another VM. All right, from A to B. And then we will use Wireshark to observe whether our request will be accepted by the receiver. If it is accepted, an echo reply packet will be sent to the spoof IP address. Okay. This one is a little bit different because this one is actually, if I understood it correctly, it's pretty easy. So you guys should be seeing my the whiteboard. So here what happens is you send out a packet, the spoofer, let's say, spoof, sends out a packet to a specific. So there's A and B. So it's going to B, but it's got an arbitrary IP, so any IP as a source. But the whole point is that we crafted a good echo request. You see that? And then B should receive the packet, believe it's a valid packet, and send back an echo reply. But the echo reply is generated by the computer. It's not generated by you. That's the difference between those two. I misread that part. So echo reply, where now the destination IP is going to be A, and then the source would be, no, sorry, not A, the arbitrary, right? The arbitrary. So the source will be B, but this is the any IP. And then you will have Wireshark in the background, and you will just corroborate that that works. Right, guys? Is that how you also understand this problem? Now that I just read it and I thought it was the same one, but now that I think about it, That's what it's saying, because if you look, somebody wrote something. Yeah, so if you look at this one, spoofing, you know, as a packet, the objective of this task is to spoof IP packets with an arbitrary source IP. We will spoof Icmp echo requests packets and send them to another VM on the same network. That's a specific VM. We will use Wireshark to observe whether our request will be accepted by the receiver. If it is accepted, the receiver will send an echo reply packet back to the spoofed IP address, so any arbitrary one. Yeah, okay, so that's all that has to be done in that one. So that means then that after the trace route, this one should be exactly like the ping 1.1.1. So let's take a read through this one. So it says here, in this task, you will combine the sniffing and spoofing techniques to implement the following sniff and then spoof program. You need 2 VMs on the same LAN. From VM A, you ping to IPX, which could be 1.1.1.1. This will generate an echo request packet. If X is alive, the ping program will receive an echo reply and print out the response. Your sniff and then spoof program runs on VMB, which monitors the LAN through packet sniffing. Whenever it sees an Icmp echo request, regardless of what the target IP address is, your program should immediately send out an echo reply using the packet spoofing technique. Therefore, regardless of whether a machine X is alive or not, the ping program will always receive a reply indicating that X is alive. You need to use scapy to do this task. In your report, you need to provide evidence to demonstrate that, yeah, it's very similar. So just do the 1.1.1. So just do that scenario. It's pretty much the same thing. So if you, for that part, if we go here, it's basically this scenario, okay? Make sense, guys? And that's it. That's your sniffing and spoofing labs, okay? If you notice, the rest of the document, the rest of the details in the PDF are basically now writing sniff and spoof in C, and that we've already covered. So you can just read through this, as I said, but my recommendation, use the code I provided. It's probably the easiest. Yeah, this is the exact same thing. All right. And then here, if you look at the guidelines, you'll just have a little bit more detail on, you know, how some functions work, etc. So, are there any questions now that I finished discussing? At this point, I have officially concluded our discussion of sniffing and spoofing, and I've completely finished our discussion of the lab. So the plan on Thursday would just be kind of an open lab. You guys can work on it, and if you have any questions, ask me. I'll point out whatever you need. I'll be there kind of just to help you with the lab assignment. These are, you know, these are kind of harder labs, so you have to just, you know, work on them, and if I can help, you know, I'll help you, but you know, somehow with this, you'll need to do some screen sharing, etc. But that's the plan. Are there any questions? Oh, all right, so it sounds like everyone is clear. That's pretty good. I'm glad. So if you guys are understanding, yeah, you know, I'll stay for a few minutes for the. I don't have anything else. I've finished this topic. What I can tell you is then this Thursday, as I said, open lab, work on this assignment. Next week, during the lecture, we will probably then start with attacks. We'll take a look at TCP/IP attacks, that discussion, and then another lab. This one's a little bit harder. All the labs are kind of build on top of each other, so make sure you don't fall behind. I haven't yet set a deadline for this. I'm thinking at least the sniffing part might be due a week from Thursday, but we'll see. All right. All right, so I'm going to stop. I'm going to pause the video at this time. I don't have any more content per se. So let me pause.